excited about today's live stream today, the Data on Kubernetes community. We are at live stream number 108, right? And we're kind of going full circle in a way with two amazing speakers that we've had on different occasions with us. Very excited to dive in very deep into this topic of running Postgres on Kubernetes, leveraging it, and the benefit that it's providing at an end user, a very interesting use case in Zalando. Our speakers are Alexander Kukushkin, who's an engineer at Zalando, very, very involved in the Postgres world, which is how we met Álvaro. We were just talking. They met at a conference in 2015. I believe it was in Ottawa. Álvaro is no stranger to the Data on Kubernetes community, having participated in various live streams, KubeCons, different occasions with us, writing things at OnGres, always ready to help out in our Slack. Great, great community member. Can't say enough positive things about him. Just for historical reasons, I would like to start with Alexander. You have a nickname, which is Mr. Patroni. Can you tell us about where that came from? How'd that happen?
Well, how did it happen? Also in 2015, exactly, we started building Patroni. Like it was based on a project named Governor, like Compose Governor. And nowadays Governor is a part of IBM, and they still using reincarnation of Governor, which called Patroni nowadays. And like one friend of ours, like from Postgres community, and his name is okay. So
Josh,
like
Marcus maybe, or
no. So Hans Jürgen. Yeah, so like he was also very happy to see Patroni coming to life, and they started like using it nearly immediately. They did a very nice contributions to the project, but like this guy also decided to name me as Mr. Patroni or like the Patroni guy.
And it stuck ever since. Okay, that's good. And if you are Mr. Patroni, I don't want to go so far as to call Álvaro Mr. Postgres, but as Álvaro says, if you say the word Postgres 3 times, he will appear just about anywhere. Álvaro, very nice to have you with us. Like I said, we've had you multiple times in the Data on Kubernetes community. Always a pleasure. Just a quick aside too, because Alexander and I were talking about events. The Postgres conference in Ibiza is still going to happen in 2022.
Yes, so all plans are still holding up. We'll probably make a final call on January based on obviously the health situation around the world. But so far, Spain, by the way, for those of you who are international, the situation, COVID situation in Spain is pretty mild compared to many other locations. And on the islands, in particular in Ibiza, is much less. So it's quite a very safe place, I would say. And unless something drastic happens, there is going to be a Postgres conference in Ibiza in summer 2022, website pgibz.io. If you want to check it out, it's going to be the last days of June, first day of July. So write it down on your calendar, block it already, start planning the trip if you want to. It's going to be an amazing conference for forward thinkers in Postgres. If you want to look into the future, if you're going to think open, you're going to come up with new ideas, this is a conference to be.
Very, very good. I am forward thinking. I like looking into the future. I'm obsessed with Postgres, and I will most certainly be there. So don't worry about that. You got me covered. I dropped the link in the YouTube chat as usual, folks. This is going to be it's always an open conversation, the Data on Kubernetes community. Today it's going to be especially open, right? So Alexander is going to start it with some slides to give us some background about how they started using Postgres on Kubernetes at Zalando. We're also going to be touching on the topic of operators. These two gentlemen have interacted on various occasions, so this conversation can go in many, many different directions. But remember, we want to know your questions, so feel free to drop them in the YouTube chat. That being said, Alexander, if you want to start sharing your screen so we can take a look at your slides, and then we'll open up the conversation with whatever Álvaro would like to ask you.
All right. So can you see my screen?
Yes.
Yeah, perfect. And as I already explained, I am database engineer, work at Zalando since 2013. And like in Postgres community, people know me as the Patroni guy or Mr. Patroni, like as sometimes Hans Jürgen Schoenig calls me. Yeah, I'm very happy like to build such an important tool for Postgres high availability, and we do regular releases, and it's a probably the most powerful horse that allows running Postgres on Kubernetes, like easily. And Álvaro, could you
Thank
please
you.
talk yourself?
So as you can see in the slide, I am the founder and CEO of a startup called OnGres. OnGres means on Postgres, so it should be pretty obvious what we do. We're highly specialized and solely specialized in Postgres. That's why everything we do is Postgres. And we have a specific bias towards research and development. So we like to come up with new ideas for the Postgres ecosystem to improve it, to bring new capabilities, and just not focus on the traditional capabilities that Postgres has, which are great, but also to enhance from an architectural orchestration, operational perspective. I've been using myself Postgres almost since all my professional life, since I started almost in the university. I have built some projects like Stackdress right now, which is Postgres on Kubernetes. Maybe we'll have some time to mention it. Today we're focused more on the real experience of Zalando. Also another project called ToroDB, which is MongoDB to Postgres live replication. I'm Amazon Data Hero, and I can find on Twitter. There you have my Twitter handle. Throw any question anytime you want. Today, I'm going to be mostly interviewing Alexander and hopefully making some tough questions for him. All yours. I think you have some introduction about Zalando, and we'll take it from there.
Yeah. So like.
Oh, one thing before we continue, Alexander, if you could turn up your volume a little bit, just someone to YouTube, maybe I was having just a little bit of difficulty, if you can.
Oh, that's a tough question. When I
oh yeah, now it's better. Now it's better. It's
yeah, great. Yes. Unfortunately, when I make it higher, like it goes back immediately. So
okay.
I maybe try to like speak louder.
That's fine. That's okay too.
Yeah.
Shout to me.
Yeah, exactly. Sing to us. Yeah.
So let's talk a bit about the scale of Postgres that we deal with at Zalando on the daily basis. Like specifically, like we will talk about Postgres on Kubernetes. So in total, we have like this is maybe not like 100% up to date number, but like it's about 136 Kubernetes cluster. It could be a little bit higher or a little bit smaller. We run Kubernetes cluster for production and testing separately, and usually we have for every production cluster one testing cluster. And specifically in this case, I'm talking about clusters where we run Postgres operator, like Zalando Postgres operator. In total, we run about 2,700 Postgres clusters, like all on Kubernetes. And if we split them between production and staging, so for production it would be around about 1,200, and remaining one are for like testing, staging purposes. Like with staging, it's a little bit tough to capture exact number, unfortunately, because people really deploying and destroying staging clusters like on daily basis. Like you can see clusters being created for every pull request being open and running through CDP, and like once CDP step successfully executed, the cluster is getting dropped. Sometimes it remains running until some janitor job comes a little bit later, like usually about 1 week after, and cleans things up. Speaking about what kind of resources do we use to run those clusters? In total, we have more than 100 terabytes of data. It's not about like allocated storage. It's really about size that we store in those 1,200 production clusters. The biggest clusters, it's kind of quite surprising. It's more than 12 terabytes. Although I'm not really proud of this number. Either it should be, in my opinion, sharded, or in this specific case, we, for example, can use timescale DB and apply compression to this time series data, and the size will become around about 1 terabyte. But still, it's a very frequent question that people ask, how big data you can run on Kubernetes with Postgres, and like here's an answer. Like basically, you are not limited. If your hardware is capable of running, like I don't know, 50 terabyte clusters, like there is no problem with it. And how much resources do we request? It's about 1 core per cluster. Of course, it's not always like just 1 core. Sometimes people request, engineers request, I don't know, dozens of cores. In some cases, they request just, I don't know, 100 millicores. Like it's 10% of CPU core. But on our Kubernetes environment, we don't have CPU quotas enforced. Even if you request just 1 millicore, in fact, you can use all available resources on this specific machine. This is like we came to this idea by measuring latency of applications, and like it's not very specific to databases, but like to every kind of applications. And without quotas, latency is more predictable and typically smaller than when you have quotas enforced. And in terms of memory requests, it's more than 4.5 terabyte of memory for running so many clusters. And it doesn't unfortunately mean that all this memory is used efficiently. Like there are cases when engineers don't understand about Postgres internals, and they may request, I don't know, 16 gigabytes of like memory for a cluster that holds only like 1 gigabyte of data. That like really waste of resources and waste of money. But unfortunately, we don't have like vertical autoscaling capabilities. Like maybe engineers really know better like about the future of their setup. Like right now, it's a 1 gigabyte, but in some like couple of months, they might expect that it will grow up to 100 gigabytes of data.
I'm actually thinking that I have already a lot of questions. So why don't we stay on this slide for a moment and look at some of those. All right, so here's the first one. So 140 Kubernetes clusters, I would say it's a pretty large number. So it's obvious that there are several environments built by role, production, testing, staging. That's absolutely understandable. And there might be different teams, totally different applications, not connected to each other. But on the other hand, one of the advantages of Kubernetes is consolidation and sharing of resources. And there's ways to isolate workloads, namespaces and pod securities, and there's a lot of mechanisms. So is it that Zalando is following a more like 1 cluster per team, per group, per environment policy? And if so, why you chose this over isolation on a larger but multi-tenant Kubernetes clusters?
It's more about 1 cluster per department or some cost unit. Like basically, it allows to have more control on money spent for a given department, for a given unit. And when you have everything isolated and spread across different departments, it's much easier to control it. And another reason is like it's probably coming from the scale that we have. Some cluster, like some of our Kubernetes clusters could have literally like less than 10 nodes, and they're absolutely fine. Other clusters can sometimes could scale out up to more than 1,000 nodes. And running something in the cluster with like only 10 nodes and 1,000 different nodes, it's a like totally different story. And like with etcd and like Kubernetes control plane, sometimes it's a big challenge to quickly scale out. When people run like for like some normal workload, only, I don't know, dozen of application instances, and for big events like Black Friday, they decide to run not 10 but 1,000 application pods. It results in like quick scale out of Kubernetes worker nodes and like pods and so on. And it's not always nice, like Kubernetes control plane or API server not always nicely reacting to such scale out. And like having multiple Kubernetes clusters also allows to mitigate such problems.
Real quick question. Are the 2,700 clusters simultaneously active?
Yes, why not? So like out of this 2,700, like it's, as I told, it's more than 1,200 production clusters. They have different kind of workloads. Some of them like absolutely read-only. Some of them like receive connections or queries like only periodically. Staging clusters could like pretty much idle most of the time, but they all up and running. They all highly available in case if one pod fails. Patroni does failover, like all these things.
Perfect. Thank you.
All right. So if I recall correctly, and I believe this is public information, correct me if I'm wrong, feel free to stop us if something cannot be shared. But I think everything runs on Amazon, and you don't use EKS, so you run your own Kubernetes clusters. So in this case, isn't it a bit of an overhead to run this large? Well, I mean, you're a large org anyway, but the benefits of being able to account better the usage per team. And I know this is a strong concept in Zalando. You have teams and everything belongs to a team, right? So there's that responsibility. But this can also be achieved by, some simple software that potentially iterates over compulsory labels that you need to enforce, right? In this case, I guess the trade-off is that it's better to still have many clusters and manage the updating of Kubernetes clusters by yourselves, even though it's a large number, versus the accountability on a per team basis.
Well, so what I probably forgot to mention, like all these Kubernetes clusters are running in separate AWS accounts. That's also
that's interesting.
important. Like in every AWS accounts, you have like your own resource limits. Like by default, like you probably know that those limits are quite small. Like, and this is for a good reason, because like in case if you get an intruder to one account, like remaining accounts are not really affected, because like it's very isolated, and with default resources being very low, you cannot start immediately like largest possible instances like available on AWS and start mining Bitcoins, for example. That's yet another reason. But like after all, the money probably is a like first driving factor, and like accountability between different teams, it's the second one. Like one department could have access only to their Kubernetes cluster, like, and to their AWS account, and they're not literally don't have access to other production accounts or testing accounts.
Okay.
Yes, like we really do run Kubernetes on our own, like, and the first reason why it is like that, because we started running Kubernetes before EKS being offered by AWS, and like all this Kubernetes cluster management, it's not a manual task, like it's absolutely automated, 100% automated. Deployment and upgrade of Kubernetes happening by Kubernetes cluster lifecycle manager tool. It does everything smart and smooth. And before actually something getting rolled out to production, it's getting tested like on different Kubernetes, like some playground clusters, like Kubernetes clusters, basically, when you get new Kubernetes release, first some staging cluster get recreated to the same stage as production, and after that, like the new release is being applied on top of existing cluster. And when everything goes smooth, the same procedure performed on the test accounts, and like production is the last one. And of course, we don't deploy everything to all Kubernetes clusters in one go. Like we can split them to multiple chunks, and like first deploy the first chunk and see that everything goes smoothly, and after that continue.
Yeah, makes sense. All right, last question before we move on to the next slide, and let's just cover what is after this one. Let's get a little bit more Postgres on this one. You mentioned a very interesting use case. So a 12 terabyte database, I absolutely agree with you. Postgres can handle this size, no problem. Even Kubernetes, no problem. We've seen that too. And potentially even more, even though at some point it definitely helps to start considering sharding, partitioning, both at different levels. It depends a lot on the use case. Now,
this specific DB is partitioned, but
like, it's partitioned already. Yeah. Couldn't be otherwise. I would be surprised otherwise, especially because you have a lot of Postgres expertise at home. Now, you mentioned especially using timescale compression. There's also an alternative compressing engine for Postgres by Citus. So is this particular data time series oriented, and that's why timescale would be a better fit? It's just because it's the first thing that you mentioned and both could fit, or have you done any study in these regards?
Well, so just speaking about the specific DB, it's really a time series data, and engineers build it on their own without even considering using some widely known extensions like pgpartman. So like they even implemented partitioning from scratch. Unfortunately, with such a huge scale, we cannot control like every deployment. We cannot control every single application. So that's what we have. I just stumbled upon this specific DB because it was huge, and like I looked inside and noticed that it's really time series data, and timescale DB is the best fit for time series. And I even tried to do an experiment with applying compression, and my experiment showed that it could be compressed down to 1 terabyte.
Perfect. Thank you. All right, let's move to the next one, and we'll come up with new questions. By the way, I'm going to keep one non-technical question possibly for the end of the topic. Everything else is going to be mostly technical on my side.
Yeah, so like with this slide, I think it's obvious. Since we on AWS, people always ask, why don't you simply use Aurora or RDS? And there are always good reasons not to do so. Like first of all, I hate when there is a vendor lock, and AWS and like with RDS offering in the beginning was well known as you get in, and after that it's very hard to get out because physical replication wasn't allowed, and logical replication in Postgres wasn't in the good shape yet. And but right now with logical replication, at least there is a way to migrate off like cloud offering of like from AWS. So like we run on Kubernetes vanilla PostgreSQL, like it's installed from pggdg repository. Like we run like we build Docker images based on Ubuntu, so we don't build Postgres on our own. Like compiling it is possible, like if we would like to, but better to use community build packages. And we rely on Postgres community support. Like sometimes we report bugs. We also have a couple of people who contribute a lot to Postgres in terms of code. Unfortunately, some of them are leaving Zalando in the near future, but this is life. So like in our setup, we have the real super user access. And I think every database engineer or database administrator will value such access a lot. It gives you a lot of control and a lot of power, like what you can do. Like maybe like if you don't have some extensions already built into the Docker image that we run, like you cannot install the custom extensions, but since we have control on how we build and run Docker like or containers, we could add like extensions that we would love to run. And one of such extensions is exactly timescale DB. Like there is no way AWS will offer timescale DB on RDS or in Aurora, like because it's licensed in a way that cloud providers are not allowed to offer timescale DB.
Yeah, this is actually a very interesting topic. Let me make some comments here. Sorry, it's not a question for you. You can rest a bit. But basically, this is a very interesting topic for me, right? Postgres extensions. Yes, for the audience, if there is someone who's not totally familiar with this concept, let me make a quick introduction. Postgres extensions are a way to extend Postgres functionality. Think of plugins for a browser, right? Something that you install easily, more or less easily, and then the functionality is augmented. And this could be augmented as adding a simple function or a simple operator or a simple stuff to the database, a data type, or it could be really advanced things like even a new language for writing stored procedures, could be time series database, timescales and extension, could be a distributed query engine, could be really like almost anything. It is a very powerful mechanism. So extensions end up being one of the very best things of Postgres. If something is not covered by core Postgres, you may likely find an extension that's doing it already, and just install the extension and you get this added functionality. Now on Kubernetes, this is an advantage versus managed services, because managed services, they want to have strict control over what is provided by the platform. So speaking of Amazon or RDS, they whitelist an extensions, and you can see a list of extensions that are allowed, and that's it. You cannot go outside those. So if you need or want to use an extension that is not on this allowed list, well, you're out of luck, right? However, on environments like a Postgres operator like Zalando's or the one that we also run, Stackdress, there is a possibility to be root, which is very important for us as Postgres DBAs, as well as installing any extensions. But let me slightly bring do a shameless plug here, because this is a very interesting topic. Now, it's a little bit difficult how to bring an extension that is not already prepared to be packaged in the container. So what Zalando has done is very smart. It's just, you can more or less easily customize a container and add a new extension. Yet still, installing new extension is not trivial from the user perspective. Most of them are only in source code forms. You need to download, compile. Sometimes they require dependencies, they require configurations, and most of the time they don't compile out of the box because it depends on some versions. It's not an easy user experience. So unless a provider, in this case Zalando, is providing you with the extension you want, it's a little bit more tougher. And particularly in Kubernetes, containers are immutable, right? So either you replace a container with a new container image that contains that extension, and you need to restart the cluster causing downtime, or there's no other way. So again, shameless plug here. Stackdress is also an open source project. We have developed a mechanism for dynamically loading extensions. So it allows you, basically the container contains no extensions. Yes, only 2 or 3 that are required for every operation that we do. And then there's a daemon which allows you via declarative YAML as usual, say, oh, I want to load this extension. You declare this array on the YAML file, and then extensions may be loaded dynamically into the container. So this is very good because it allows us to support almost any extension that is available and to load them dynamically. One of our goals is to support hundreds of extensions. There's now more than 120 supported, but there's more down the way. If you're interested, I gave a talk at KubeCon North America a few weeks ago about this topic in particular. So I'll just try to share the link right now. And if you're interested, just go and watch it. So yeah, extensions, back to the topic, are one of the reasons why you may want to be on Kubernetes. What else?
Yes. So what else? Since we are talking about like benefits that we can get from Kubernetes, like with Kubernetes, it's one of the probably most used approaches to run or like manage something as an infrastructure is a code approach. Like when we deploy Postgres cluster, it's literally a small YAML manifest. And for production, developers don't even apply this manifest manually. They store this manifest in Git and it's getting applied via CDP. And in case if you do a change, like it transforms to a pull request. And again, it's once getting merged, it's applied via by CDP. And in my opinion, it's one of the best advantages that Kubernetes can provide. Like last but not least, since we have all controls on what we run and how we run, we can provide a very close integration of our Postgres as a service platform with rest of applications that runs on Kubernetes and like remaining infrastructure. For example, identity and access management topic is very important. And when developers create a cluster, they also sometimes want to have access to the cluster with their own user. But like we don't create like we create only a database user for the employee, but we don't create credentials, like for example, a password. And the developer or employee, when accessing the Postgres cluster, they're using tokens instead of password for authentication. And like those are the same tokens that are used for authenticating on remaining of our infrastructure. Like whatever resource you open in the browser, like you can use the same token in order to authenticate in the database. And like in order to get this token, we IAM team can enforce all the things like second factor, for example, and so on. Since like we don't have to deal with passwords for employee access, and once employee, for example, departing the company, their access is getting locked, and tokens more or less automatically become invalid. So we like really solve a lot of problems with it. And the last one, observability. Once database deployed, it's automatically getting plugged to all monitoring systems. In case of like, for example, Patroni fails or there is AWS outage, we as a database team like get paged in case if primary is not running on a given cluster. But that's not the only use case. Like we also monitor all kind of performance metrics in the Postgres, and like it's getting plugged to all these monitoring systems out of the box, just because like it is so easy to discover new resources. So yeah, like like before we started actually run databases and Postgres on Kubernetes, we did a long way, a long journey. Like we were running in the data center on the bare metal Postgres since 10 years already. And even back then, like 9 years ago or so, we have been using containers. Like it's Docker didn't existed yet, but I think everybody knows about LXC containers. And it's a pity that many engineers still think that containers are black magic, and that they produce very high performance impact, and they staying away from containers. But probably these people don't even know that like if you run modern Linux system, like with systemd and C groups, you already sort of using containers implicitly. That's like containers, it's just a C group, in fact, that's it. And like running application on your laptop and running application in the Docker container is basically the same. And as I already told, infrastructure as a service and GitOps, when you do everything like with pull requests, when you can apply 4 eyes principle to every change that you do on production is like very important. And it's one of key components of our like Postgres as a service. But developers like that came to Kubernetes from bare metal, let's say, expect from databases something like the same behavior that was before. And in data center with on-premises like hardware, you don't have so many disruptions. You don't have so many hardware failures. But on Kubernetes, when you apply new Kubernetes major release, you have to not even major release, like even with minor releases, you have to rotate all worker nodes, and it results in database failover or database switchover. Like switchovers are more often happening, but like those are expected, and application need to know how to handle such situations. Like when switchover happening, all connections from the application to the database are getting interrupted, and they have to reconnect. They have to perform the same like query, like once again, maybe like they need to implement retry mechanism, and preferably
with backup, right?
Yeah, with exponential backup.
Exponential backup.
Yeah.
Yeah. There's a famous quote by if I'm not mistaken, by Werner Begels from Amazon, who said, "In the cloud, but in general, everywhere, everything fails all the time." Meaning that you really need to be prepared for failure. The cloud and these dynamic environments, Kubernetes no exception, they are designed not to be 100% reliable, but to allow you to cope with failure. So you really need to be prepared for failure and be ready for it. There's actually specifically of Postgres, to be honest, from an application developer's perspective, it's not trivial. First of all, from the connection perspective, so what do you do? Let me digress here a little bit, but what do you do when a connection fails? Well, you get an exception on your application or whatever return value, depending on your language, but essentially you're saying connection has been dropped, the socket has been closed, whatever, and you need to restart, retry again. And you cannot retry continuously because you're going to overload whatever is going to be on the way. So you do need to do, or you should be doing exponential backup, as Alexander was saying right now. But still, you don't know if your previous query finalized completely or not. So you have two things to do here. One is to either do all the time idempotent queries that you can run more than one time without changing the state of the database. That's hard, and that's not how most people work with, but I mean, that's just one option. It might be applicable in some use cases, make things simpler. The other alternative is that there's a function in Postgres that allows you to query the state of a previous transaction, but you need to capture the transaction ID first. So it's also not an easy life. But anyway, there's something to take into account. Let me link this with, there's a couple of questions I've been watching on the YouTube channel. One of them is somehow related to this. So let me start with that one. Are you using connection pooler or PG bouncer in particular in your setup? And if so, where is it staying? Because it also can help with reconnection problems.
Well, so in our case, most of applications are using like JVM stack, and they rely on client-side connection poolers, like something what is well known in the community and trusted. Like one of them is BoneCP, I think. Another one is Hikari CP. and this is what most of applications are using. And like in many cases, there are like very limited number of application instances, and they in total don't open more than, I don't know, like 100 or a couple of hundred connections to Postgres. And like this is kind of absolutely fine. There are unfortunately also extreme cases when there must be hundreds of application instances running. And in this case, we really use a PG bouncer in front of Postgres, because scaling to a few thousands of connections, like there is no good story like in the core Postgres for such situation.
There isn't. Here, let me also explain a little bit our philosophy. In Stackdress, what we do is we always include a sidecar with PG Bouncer. You can disable it if you don't want to have it, but by default it's built in. Because as you have said, in Postgres, if you try to overload with a lot of connections, it doesn't behave. I mean, it will still be there. Postgres is not gonna go down, but performance may be really abysmal. So either you really control the number of connections that go to the database, and I'm sure that at Zalando you at least have more control, best practices, because you still are a single company. But our consideration is that we have seen with many customers of our professional services that a lot of people try to really overload the database with the connections. And this is the reason why we always consider setting up a PG bouncer just in front of Postgres, so it runs as a sidecar, connects via Unix domain sockets for maximum efficiency, but it's always fronting Postgres unless you disable it. That doesn't mean that you cannot set up even middleware, what we call middleware PG bouncers, like deployed as a deployment, Kubernetes deployment, fronted by a service, so that it also acts as a middleware between your application and this connection pooler layer. So it really depends on your use case and the expected users that will be using Postgres. But summary is, yes, this is a not solved problem. There's been some improvements in Postgres 14 in terms of keeping good performance with a higher number of connections, but still, it's not problem solved. There's a significant memory consumption. It's not solved at all. So yeah, keep the number of connections hidden in the database low. If possible, use a connection pooler. Very quick question, by the way. I think I know the answer, but I'll leave it on to you. When you mean Postgres cluster, you mean a set of machines running replication with a single primary, not an instance where you have multiple databases inside, because that's the Postgres definition of cluster.
Yeah,
I mean, you mean the engineering definition, right?
Like Postgres terminology is hard. Like when I say cluster, it could mean both like the cluster that contains multiple databases inside, and the cluster that like involves like multiple replicas and streaming replication between the primary and replicas.
Okay, that's what I thought.
Like in our case, actually. Pretty much all the time there is just a single database in the cluster. Like it's extremely easy to deploy a new cluster like on Kubernetes with operator and Patroni and so on. And you just don't need so many databases in a single cluster. And like automatically you solve all these problems. Like questioning, like we have binary backups with continuous archiving. How can we restore a single database from the cluster? Well, so you just have one, so you don't have this problem.
Okay. So by the way, a more generic question. Like other than Patroni, obviously, and the operator, Patroni is built into the operator, to Zalando's operator. We also use Patroni. Fantastic tool, Mr. Patroni. Now, what other things were needed to fully switch to Kubernetes? Even though you were running already in containers, but what else was needed? What challenges, were tools, what was required to fully switch to Kubernetes?
Well, so first of all, I think like we need to change like the mindset totally. Like we are not in the data center anymore. Like things evolving, things are changing, and you have to experience different problems. Like some new problems things could fail on different, like on new layers, let's say. People like are very hard in changing their mindsets, and like what we observed, like a few times, that people try to still do everything manually, even on Kubernetes, although all the processes like we have like all good practices we are trying to inform. Like once we've seen the old school DBA logged into our Postgres database, like Postgres clusters, locked like exec into the container, and created a swap because Postgres was killed by out of memory due to like not enough memory being requested. Like we have seen that people by mistake delete, like or not or intentionally start deleting Kubernetes objects like that are necessary to run clusters. Guys, I'm very sorry. I need to plug my laptop to power.
That's okay. That's okay. That's fine.
I'll be back in 1 second.
No problem.
Okay. Now we actually get a chance to improvise, because this is something that I used from Álvaro that we talked about a long time ago. Well, a long time ago. It was this year, but it was some months ago. Favorite Kubernetes feature is still CRD, you would say?
It's still.
Now here's a little test. Do you think that Alexander would agree, or what would you imagine his second favorite feature might be?
Let me stay with the first part. I don't know what's going to be.
That's fair. Yeah, that's fair.
I'm not sure what's going to be his favorite, but let me explain why CRDs are my favorite one. So, and I see because the approach we have taken in Stackdress is CRD heavy and not so much in Zalando. So it might not be, but maybe you'll still agree with me. So anyway, why I love CRDs so much? CRDs, so Kubernetes is all about express your architecture, right? Your deployment in a declarative way. So you specify the intent, what I want to have. You don't say how it's going to happen, which node is going to run. So that's how you stop caring about the nodes and all these things, right? The pets versus kettle, blah, blah, blah. Now, the question is, if everything is declarative, then you can make it very high level. And very high level means less friction for the user, more functionality behind the scenes. So the idea of operators is to encode domain-specific knowledge. In this case, Postgres, talking about Postgres, encode into the operator's business logic itself and free the user from having to be an expert in this subject matter. So one of our focuses in Stackdress is to make Postgres deployment so easy that anyone without Postgres experience can do it. And normally, even to operate, like day two operations, you still require Postgres expertise. We're trying to get rid of all this so that anyone could deploy and operate production quality Postgres clusters. How do you do this? Essentially with CRDs, because the CRDs is a way to extend Kubernetes API in the same declarative way. And then CRDs, you can still make them like tightly coupled or very transparent to what you're trying to do, or try to make them like very high level. And if you craft CRDs that are very high level, that hide away all the implementation details of how things works behind the scenes, and just offer users a very simple to use API, that becomes the user API. That becomes the user input. And that's, in my opinion, the best feature of Kubernetes, because it allows to create this easiness of use for users. Some people say Kubernetes is very complex. And I mean, understanding Kubernetes may become very complex because it's very big. There's a lot of features and built-in objects there. But if you just consume Kubernetes and just use the APIs, being the APIs a pod, yes, pod can also get complex, but you can also write a pod in 6 lines of YAML and deploy an Nginx or whatever, right? And if you can do the same with Postgres to deploy a Postgres cluster or to run a PG repack, which is an operation on Postgres that requires some level of understanding. If you can deploy with a 6 lines of YAML file, this is really high value. And if you compare to other alternatives, sometimes Postgres is compared with, like, for example, Nomad from HashiCorp. The big mixing point in Nomad, for example, are CRDs. So for me, it's a real key differentiating factor, and that's why it's my favorite Kubernetes feature. What do you think, Alexander?
I'm muted, but Alexander, I took advantage when you were getting your computer charger to ask Álvaro a conversation we've had before. Do you agree? Is that your?
I've been following.
Oh, that's right. Yeah, you have Bluetooth headphones. Good job.
So, yeah, exactly. So, yeah, I totally agree. Like CRD is like one of the most interesting and important features. Like because like having an environment that you cannot extend and like having something what is very extensible like Postgres, like two different stories, and like being extensible, it's very important, like from all kind of perspective. Like if you're missing some feature, you can easily build one.
Very, very good. Like it. Good stuff. I'm asking the audience as well too on YouTube to see what they might have to say. So anyway, that'll be interesting. Guys, continue. Go for it.
All right. I see one question in the chat window that we might want to address. But let's go fast on this one because I would like to keep a couple of questions for the very end for you. So let's go with this question. So how do we handle out of memory in Kubernetes? I'm going to ask this in 10 seconds and pass it to you. Well, pretty much the same way you do without Kubernetes. So this may happen. There's potentially no ways to control it because if you allow too many connections and each connection uses a lot of memory, you may be under a situation of memory stress, which can lead to OOM. In Kubernetes, this may happen earlier because of the limits, but still the same problem. There's some tools and some answers. But Alexander, what's your take on this?
So like with out of memory, there are two kind of things that we observed. Like one is obvious, like when you allocate like too few resources, like memory resources, and it's getting killed apparently. Also, we trying to apply sort of smart configuration, set shared buffers, size of shared buffers to 20% of like allocated memory, like for the pod, for the container. But it seems to be not enough, like because Postgres itself needs some memory, like Postgres connections require some memory. Patroni, like again, needs some memory. Like your favorite backup tool, like we use Wally or Volg. Like if somebody uses pgback rest, like they all use memory. But one thing that was not very obvious to find, it's amount of dirty buffers. Like that is not possible to limit per container. And by default, on Linux systems, dirty buffers on the machine are allowed to grow to some incredible sizes. And they, by default, they configure to, I think, 10 or 20%, like there is dirty buffers and background dirty buffers, and they configure it to 10 and 20% of available memory on the machine. And like if you have a machine with 32 gigabytes of memory and you have a container with just 1 gigabyte, which is perfectly fine for your small DB. But your small DB could generate a lot of write activity. And if your disk storage, like system, like subsystem, like in case of AWS, it would be EBS, cannot keep up with your rate of writes. It results in accumulating a lot of dirty buffers. And at some moment, the amount of dirty buffers become so high that they really approach your gigabyte of allocated memory. And you cannot really control from inside the container this value.
Yeah, there are some challenges and some differences.
Yeah, so like it took us really months to investigate this issue, and and after all, we just set it on the node level. All right, so we want to limit amount of dirty buffers by like 128 megabytes, just on the node level. And that's it. And like all our problems magically disappeared, related to these dirty buffers. And like these problems manifested themselves not only by out of memory being triggered, but like once dirty buffers getting higher and higher, Linux kernel starts paging off normal processes, like including Postgres, including Patroni, and Patroni does not have resources to run. And like the next time when it needs to do the like Postgres health check and update leader key, like in Kubernetes API, it simply needs to bring its memory back from the disk. And basically, it means that Patroni wasn't able to run every 10 seconds as it's supposed to, but like it could take up to 2 minutes to get it back. And it was hard to investigate.
Yeah, and there's other issues. There's also Postgres uses a lot of shared memories, how it operates. So you also need to bump the shared memory segments that you are allowed to book on a container by default. There's a lot of things to do there. All right. I don't want to go more than the allotted time that we have. Still have 2 questions for you. So let's make it 2 minutes per question. The first one is a technical question, and the last one is maybe not that much technical. So anyway, what is the future? What would you like to have, or what you're planning to do, or what you wish? What is your ask to Santa or Three Kings, whatever you believe in, that you would like to see on Postgres operators, being it Zalando or others? So what do you want to see? What do you think the future is?
Well, so it's not a very specific about like Postgres operator or about Patroni. Like it's more questions about what Postgres offers to us to build such kind of automations. For example, right now, when like replica cannot like when the write ahead log file is missing on the primary and replica trying to stream, and like this file is missing, like there is no good feedback mechanism. There is no API to discover the situation. Like the only we can do, like look into Postgres logs. And like if we talk about distributed systems, it probably means that logs are getting written to standard error and like immediately sent to some log system. And like you cannot always access to like this login system, and you cannot figure out what is wrong. And it really stops us from the next, from better automation of everything. Like if we can detect such situation, we probably can reinitialize such stale replica. But right now it like stays forever, and we get tons of questions like because of that. And like we can continue, like there are plenty of things like in Postgres that could be improved to run better on cloud environments. For example, plenty of Postgres parameters require restart to be applied. Like you cannot, for example, extend shared memory or increase max connections like without restart. And
yeah, those two. All right, very last question. This one not so much technical. So it's a bit of a joke. So what is Zalando doing building a Postgres operator and a Postgres high availability solution? Because as far as you know, as I know, you're in e-commerce. So again, kidding a little bit, because I know a lot of people at Zalando. It's a fantastic tech team. But what are you doing so heavily invested in Postgres, and what is the future? Are you planning to continue doing this?
Well, so since we run a lot of Postgres workload, and so far it was very, very successful with Kubernetes. Yes, we continue doing so, and like we even sometimes build the features that we need in Postgres that apparently missing and contributed back. We also have not well, so like there is a thing that we're trying to push back to the core Postgres, but like we run it internally. For example, like enhanced pgstat statements that like can combine multiple in values into like something that is small.
Yeah.
Yes. So like if we run something like where we have like full control, we can get way more out of this environment. And like one of the recent features that was added to Patroni, it's failover of logical slots. And like if people decide like rely on change data capture and logical decoding, it's very essential. Like because after failover, like you want to continue replication not from some later position, but like from the same or maybe a bit earlier, like in order not to lose events. And Patroni like allows us to do so. Like, and we like I really continue to improve in Patroni, like maybe implementing some new features and or at least fixing some bugs that are being reported by community.
Yeah, this one is a really good feature to be able to continue streaming from a logical replication slot. Thank you for all the work you're doing with Patroni and Zalando for all the work it's doing in the open source part of it. So I think this is it from my side. Of course, I have my brain boiling of new ideas on questions, but I think that's going to be it for today. I think we can call it a day. But Bart, it's on you.
Yeah, absolutely fantastic. I think we all got what we were looking for, a great conversation between two very wonderful people who know a lot about Postgres and are always helping other folks kind of push the limits and take things further. I think the results are clear that if you have doubts or interest in this, you definitely need to continue the conversation with Álvaro, with Alexander, with both of them. You can do so in our Slack. Alexander, could I get you to stop sharing your screen really quickly?
Yeah, sure.
Very, very good. As usual, folks, we have more live streams coming up. You can always find out about that on meetup.com. But what I want to do right now is I want to share my screen, make sure that I've got everything lined up. While the two of you were talking, as usual, we have our fantastic artist, Angel, who's lurking in the shadows. I'm sure you can see what he did now. Very, very nice drawing of the two of you, artistic depiction of some of the things that were talked about. Really, really practical stuff here. Very helpful for the folks out there that are curious about this, that want to take it further. That's why we have these conversations, so that running data on Kubernetes isn't so scary. We also put the link to Álvaro's talk from KubeCon about Kubernetes extensions. Definitely check that out too. As always, we're very easy to find: Twitter, Slack, LinkedIn. We love continuing the conversation. So if you have any questions or doubts, feel free to drop them in there. Thanks to both of you very much. On Thursday this week, we also have a Postgres talk with Gabriel from EDB. So he'll be talking about Postgres as well on Thursday. So if you have deeper interest that you would like to continue there, he'll be doing the second part. They did a part 1 in KubeCon, so he's going to complete that on Thursday. That being said, thanks to everyone. We'll stay in touch. Thank you very much, Álvaro and Alexander.
Awesome drawing. I love it, as
yes,
usual.
Good.